We are going to start section 10.5. And before we start it, we're going to do some experimenting like we usually do. So what you need is a protractor and you need a picture of a circle. You can either print out the one I sent you, or you can just draw your own if you have a compass, or try to draw a circle as best you can, follow along, whatever. All right, so what you need is a picture of a circle and then draw in a radius of a circle with the center. We're going to start with that. Then before you take your protractor, put a point on the circle where the radius touches the circle. And that's the point where I want you to make a 90-degree angle with your protractor. So when you create your angle, it should come out looking somewhat, let me see if I can, don't do what I'm doing. You should be using a protractor, not a ruler. I'm trying to do my best here. So when you draw the line that you made, it should come out looking like that. Okay, and that should be a 90-degree angle. Mine's probably not perfect because I didn't use a protractor, but it's pretty close. This red line that we just drew is called a tangent. And a tangent could be a segment, it could be a line. It's just basically a segment or a line that's on the outside of a circle and it touches one point on the circle and it's perpendicular to the radius. So let me just say that. Sorry about that. Let me say that all over again. So the tangent line is number one, perpendicular to the radius. And number two, it touches one point on circle. Okay, so this is experiment number 2. And this time I want you to, again, draw a circle, but this time draw 2 radii. There's nothing special about the angle that the 2 radii are making. Just make sure that you leave yourself a ton of space surrounding your circles so that what you're about to draw isn't going to fall off the paper. Okay, so that's what I'm going to do. Now, this time, what you're going to do is you're going to make 2 90-degree angles. So the experiment number 1 that we did, you made one tangent. You made a tangent, obviously, that was perpendicular to the radius. This time, you're going to draw 2 tangents, one for each of the radii that you're looking at. So again, get a protractor and make 2 right angles to each of your radii. Again, don't do what I'm doing unless you don't have a protractor, but you guys better have protractors after all the protractors I've given you. All right, let's see if this thing works for me. So here is one tangent. And again, you should be doing this with a protractor. There we go. Here is the other tangent. Okay, so this is a tangent, and this is a tangent. And notice that this one intersects the radius at a 90-degree angle, and this one intersects the radius also at a 90-degree angle. Okay, so far we've made 2 tangents. Now what I want you guys to do is find the length of the piece of each tangent from here to here. So tell me what the length is here. And then from here to here. Pause this video, measure it, and then come back to me. All right, so we're going to continue. I'm going to erase this part because that part is not important. So I'm going to erase all that and all of this. And really what we should be looking at is just the two pieces I was asking you guys about. And what you should have found, what you should have figured out is that the red piece is congruent to the blue piece. So that's our second rule, that if you have two tangents that intersect outside the circle, oh my gosh, intersect outside circle. So again, if you have two tangents that intersect outside the circle, then those two tangents are congruent. These two tangents are congruent. So for example, if this was A, B, C here, then I would say that AB is congruent to BC or CB, whatever. Okay, so that's our second rule. So notice again, we've got the 90-degree angle. Tangents are perpendicular to the radius. And we also have the two tangents congruent. And that's basically the essence of 10.5 part 1. All right, so here's 10.5 notes part 1, tangents. Let's just go over what it says here. A tangent to a circle intersects the circle in exactly one point, called the point of tangency. All right, I don't know if I mentioned that. That's called the point of tangency. Right here, R is a point of tangency. T is a point of tangency. In other words, it's the point that the tangent touches on the circle. And we went over both of these. A line is tangent to a circle if and only if it's perpendicular to a radius at a point of tangency. So in other words, here, okay? And if two segments form an exterior point, this, are tangent to a circle, they are congruent. So let me erase all of this stuff. If you have two tangents, 1, 2, if those are both tangents, then we know that RS is congruent to TS. All right, so those are basically the two things that we went over. All right, let's look at this question. AB is tangent to circle C, right here. AB is tangent to circle C. The radius has length 8. The radius, right here, that's the radius, has length 8, and AD is 9. AD, right here, is 9. Find X. Okay, so we have a right angle right here. And we also know, like, you might be wondering, what in the world is that piece right there? They didn't give us any information. Well, that piece is also a radius. It's also a radius right here. So if the radius is 8, then this is also 8. Okay. So what you would do is 8 squared plus x squared equals, now how long is this? 9 plus 8, 17 squared. Now, if you don't already know, this is a Pythagorean triple, the 8, 15, 17. If you didn't know, you could just figure this out. But if you did know, you'd know that the missing length, AB, is 15, the 8, 15, 17 triangle. So at this point, you should probably pause this. If you have an idea of what to do, you should pause it because I'm going to go over each question. So, I'm just going to keep going and you pause wherever you need to pause. But I would suggest that you do it on your own instead of just watching me do it because that's going to get kind of boring. And then just, look for the answers and go through the video. All right. So here we go. Here we have a tangent because they tell us everything, all the segments that appear to be tangent are tangent. We're assuming. Okay. Assume that segments that appear to be tangent are tangent. So here I have a tangent CB and tangent CD. And remember, we found out that tangents are congruent if they intersect at the same point on the outside. So I know that x plus 3 equals 7. And then you just solve that. So here's my x. Finished. That's an equal to sign, not a greater than sign, okay? All right, next one. Here I have a tangent right here. And here I have a radius. And remember that the tangent is always perpendicular to the radius at the point of tangency. The point of tangency is point J, by the way. So here we have a right triangle. We're looking for x. X is the hypotenuse. So I have 15 squared plus 20 squared equals x squared. You may not recognize this as a triple. Let me just show you 15, 20, blank. If you divide by 5, you're going to get a 3, 4, 5 triangle, and then just multiply by 5. So it's a 15, 20, 25 triangle. But you can also figure that out using Pythagorean theorem. So I'm not going to go through this. I'm assuming you guys know how to do all of that. So you should get x equals 25. All right, number 3. Again, I have two tangents. Oh my goodness, that's not what I wanted to do. I have two tangents, and when two tangents meet at a point on the outside of a circle, they are congruent. So 12 equals x. That's it. All right, that's the shortest question you're ever going to have in math class, probably. All right, number 4, we have a radius, we have a tangent, so they have to be perpendicular. So I have 15 squared plus 36 squared equals, what in the world is this? Well, if the radius is 15, then that's also a radius, so that's 15. So how long is this thing? Well, here I have x, here I have 15, and together they make x plus 15. So I have 15 squared plus 36 squared equals x plus 15 squared. Okay, so this is going to end up being quadratic, and I don't want it to be quadratic. So I'm actually going to not do it this way. What I'm going to do is take this part out, and I'm not going to call it x plus 15. I'm just going to call the whole thing y, or whatever you want to call it. So I'm just going to make this y squared, and that gets rid of the quadratic part of it, which is, would make it more difficult to do, and who wants to do that? So 15 squared is 225. And I need to get my calculator for this one. 36 squared is 1296 equals y squared. That's 1521 equals y squared. Take the square root of each side. Y equals 39. Okay, now I'm going to go back here and I have y equals 39. But that's not my answer. I'm looking for x. Well, if the whole thing is 39 and a piece of it is 15, then all I need to do is do 39 minus 15, and that gives me my x, and that's 24. X equals. Okay. If any of you are interested in seeing how to do it using my original setup with the quadratic, I'll be happy to show that to you. Just let me know. All right, number 5. Number 5, we have a tangent right here. We have a radius right here. Again, this piece right here is 21 because that's the radius. So together, this whole thing is 21 plus 8, or 29. My right angle is over here. This time we're looking for a leg. The leg is missing. So I have 21 squared plus x squared equals 29 squared. So that's 441 plus x squared equals 841. Subtract 441 from each side. X squared equals 400. And therefore the square root is 20. That's it. So here we have a tangent, here we have a radius, and we have the missing segment right here. So I'm going to erase this part right here because that's not part of our triangle. We have a right triangle, so I'm just going to do 24 squared plus 17 squared equals x squared because that's our hypotenuse. It's opposite the 90-degree angle. 576 plus 289 equals x squared, and that is 865 equals x squared. Take the square root of each side, and that's roughly 29.41. I don't know if it asked us to round a certain way, but whatever. If you get something like that, you're fine. And that concludes 10.5 part 1.